Okay, sorry about that. I had a little glitch. So we were looking at number 2, and we set up our variable. C is the number of candy bars bought. So we're going to go back and read through this again. With story problems, you really want to read it over and over and make sure you get the important information. So you bought a magazine for $7. So we know $7 is just a concrete number. That's what they spent. And then some candy bars for $4 each. We don't know how many. That's what we're looking for. C is the number of candy bars. So we can represent that with an expression. We're starting with $7, and then we're going to have $4 times however many candy bars they bought. So 4C. And then it says you spent a total of $35. So if I add up the $7 for the magazine and the $4 per candy bar, we get a total of 35. All right, so we want to get the term with C in it by itself, so we'll get rid of the 7 by subtracting 7 from both sides of the equation. Bring down the 4C, and we'll go ahead and subtract 35 minus 7, and we get 28. Now we have a one-step equation. 4 times C is 28, so we'll divide both sides by 4, and we get C equals 7. So let's go back. So C stands for the number of candy bars bought. So the 7 means that they bought 7, or you bought 7 candy bars if you're reading the problem. So we're just going to label our answers for today, and we'll talk about going more in depth with writing out our solutions in the next lesson. All right, let's take a look at number 3. For a field trip, 4 students rode in cars and the rest filled 3 buses. How many students were in each bus if 145 students were on the trip? So they've sort of mixed some information in with the question, but you can still see the question here. How many students were in each bus? You always start with the question, what am I looking for? And then we're going to assign a variable. So I'm going to use B and say that that's the number of students per bus. And then we'll go back and reread the problem and find important information. So for a field trip, 4 students rode in cars. Okay, so that's important. I'll underline that. And the rest filled 3 buses. So we've got 4 students that are kind of separate, and then we've got students on 3 buses. So we can write an expression for that piece. We're starting with the 4 students that are by themselves. And then we have 3 buses full of students. So we can write that as 3B. Because there's 3 buses times the number of students that will go on each bus. And then the total will be 145. All right, so to solve for B, first we're going to subtract 4 from both sides. That gets rid of this. We get 3B equals 141. So 3 times B, we want to get B by itself, so we'll do the opposite of multiply, which is divide. Divide both sides by 3, and then 141 divided by 3 is 47, and I'm not magic, I did that on a calculator already. So if we go back to what that B represents, that's the students per bus. So we can say 47 students per bus. All right, let's look at number 4. Jacob rented a bike from Alberto's Bikes. It cost $11 plus $5 per hour. If Jacob paid $46, then he rented the bike for how many hours? So we're looking for he rented the bike for how many hours. It's sort of mixed together with information again, but that's what we're looking for. So we're trying to figure out how many hours. So I'm going to assign the variable H to represent the number of hours that the bike was rented. Then I'm going to go back to the beginning. Jacob rented a bike from Alberto's Bikes. There's no numbers there, nothing that's really important. It's just letting us know what the problem is about. It costs $11 plus $5 per hour. I love it when they put the word plus in there because that tells me for sure there's going to be a plus sign. So he pays $11 plus $5 per hour. So that means $5 times the number of hours that he rented the bike. And then the total was $46. Jacob paid $46. If I take the $11, add on the $5 per hour, the total is $46. So that becomes the other side of the equation. And we solve just like we did the others. Subtract 11 from both sides. So we get 5h equals 35. And then this is 5 times h, so we will use division to get h by itself. So divide by 5 on both sides, and I get h equals 7. Let's go back and see what h meant. H was the number of hours that the bike was rented. So my final answer is going to be 7 hours. All right, so the first 4 problems were all of a certain type. If you look at the equations, they're all very similar. The bottom half of the examples is a little bit different. So if we go over here to number 5, we can read that one. Mark won 29 super bouncy balls playing the beanbag toss at the county fair. At school, he gave 2 to every student in his math class. He only has 5 remaining. How many students are in his class? So what we're looking for is how many students are in his class. So I'm going to let S represent the number of students in the class. Okay? So let's go back to the beginning. Mark won 29 super bouncy balls playing the beanbag toss at the county fair. Starts with 29 in the problem. I'm going to start my equation with 29. At school, he gave 2 to every student in his math class. So we started with 29, and he gave 2 to every student. Now, if we're giving those away, that's going to take away from the 29, which means we're going to subtract 2 for every student. So he's giving 2 balls for each student, and we have S students in the class. So it's going to be 2 times S, which we just write as 2S. No need to put the times sign there. And then at the end of the problem, he only has 5 remaining. So if you started with 29, you gave away 2 per student. Now I have 5 remaining at the end of the problem. These start a little bit like the equations that we did before. We would subtract this 29 off of both sides. The difference is we are going to work with some negatives. When I bring down the 2s, remember that this minus sign will change to a negative 2s. And then 5 minus 29, if you remember the keep, change would be the same thing as 5 plus negative 29, which will come out to be negative 24. All right. So I have negative 2 times s equals negative 24. So to get s by itself, we divide by negative 2. And over here, I've got a negative 24 divided by negative 2. Remember the song about multiplying and dividing? If they have the same signs, the answer will be positive. So I really just have to think about 24 divided by 2, which is 12. Now if we go back, 12, this S represented the students in the class. That means that there are 12 students in Mark's class. So we'll just label it as 12 students since we're running out of space. All right, let's look at number 6. How old am I if 400 reduced by 4 times my age is 152? It's one sentence. It's very short, but there's a lot of information. The first thing you want to identify is the question, which is how old am I? So I'm going to use age to represent the age I am, or that this person on the problem is. So it's going to represent an age. 400 reduced by 5 times my age is 152. So we start with the 400. Reduced by means subtract. 4 times my age would be 4a. And then that is 152. So is tells me that's equals 152. Whenever you see that is or is total, you know that's the other side of the equation. So 400 reduced by 4 times my age is 152. If I read it all back to myself, I can make sure that the story that I just wrote as an equation makes sense. So if we subtract 400 from both sides. I get negative 4a equals, and this one's kind of a tough one. This might be a good calculator problem. Remember that this would be the same thing as 152 plus negative 400. So the negatives are definitely going to win this struggle. There's more over here than there is here. You really just want to think about subtracting 400 minus 152, which gives us 248. And because there are more negatives than positives, it would be negative 248. All right, so I have negative 4 times a equals negative 248. I'm going to divide by negative 4. That leaves me with a equals 62. If I go back to what that represents, that's the age. And so I would label that with years. That would be the age.